Coders. I hope you're fine, doing well in your life. So today we are gonna solve the problem of the day for 17th February, right? So due to some personal reasons, I was unable to upload the videos for 15 and 16 February, but we will start with 17th February again. So the problem is, actually I have tried this problem and solved the one. So I will gonna explain you this, right? So the problem is letter tiles possibilities. So before starting the problem, I have something to share with you, that we're gonna solve this problem. So we will discuss all the details before solving this problem, right? So the details including what is given and what is expected from us, right? So this is the we are following the structure of interviews, right? And after discussing the detail, we will discuss the native approach. So what we will discuss the details, we will discuss the native approach, then we will discuss the optimized one, right? And also this is the problem of LeetCode problem of the day series. So this video is the part of LeetCode and problem of the day series. So we are committed to solve LeetCode problem of the day regularly, daily, so that we will build our profile well, right? Along with this LeetCode problem of the day, we are also solving LeetCode 75, right? So the link of the playlist is given in the description box, you can check. Along with this, I have also created a WhatsApp group. You can join that group using the link in the description box, which so that will be very good if like you can discuss multiple things in the group. You can directly ask any doubt, anything which you want, and we can also start some good projects for our resumes, for freelance work, anything which you want, we can do that, right? So that is also suggested that you join that group. So let's start with the problem. The problem is letter tiles possibilities. So you have n tiles where each tile has one letter, tiles I, right? Printed on it. Return the number of possible non-empty sequences of letter you can make using the letter printed on those tiles. So let's say we have n tiles, right? So these are the tiles. So we have A and B. So what we want to do, we want to make maximum number of subsequences of non-empty tile. So maximum number of non-empty subsequences of letter you can make using letter printed on those tiles. Okay, so that is a very straightforward solution, straightforward question. This is a very standard problem in which we have to make maximum possible subsequences, right? So given is a tile. So tile is given as a string of characters, and we have to return the maximum possible subsequences, right? So how can we solve this problem using native approach? So native approach is nothing but the first approach which came in my mind. That is the most basic approach which we can do, right? So finally we will gonna solve this problem using backtracing, but before that we will discuss the native approach, right? So what we can do, so there are total 2 to the power n minus 1 cases, right? So as you can see, for any items of length n, we can make 2 to the power n minus 1 subsequences. So that is a very standard formula. So we can use that formula for solving this in a native approach. So what we can do, we can create all these subsequences, right? We can create all these subsequences, and then we have to remove the duplicate subsequences. So we can make a set. We will make a new subsequence and we will put it inside the set and return the length of set. So that is the native approach. But the problem is, this is not recommended problem, because we can solve this using backtracing in a very efficient manner. So let's try that method out, right? So I hope you understand the details and the native approach. I've not explained the native approach very well, because there is no very so that is a very most like, there's a similar type of approach. So we will gonna solve this efficiently using backtracing. So what we gonna do, right? So what we will do, we will choose one tile, right? So let's say we have, so what we'll do, we will do three operations, right? So first we will count the frequency of all the characters, right? So count the frequency of all the characters. So in this given so let's take the example of this. In this given example, we have A 3 times, we have B 2 times, and we have 1 C. Okay, and then we will use the method of backtracing. What we'll do, we will first choose any character, right? We'll first choose any character. Let's say we have choose B. So in our frequency map, total frequency of B will become 1 for this case, right? For particularly this case. Then we will count the number of subsequences which can be made using these frequencies, right? And also, let's say we have something here, we will choose B, right? So this is also a subsequence, and appending to these also the subsequences, right? So using this method, we can count all those subsequences. So what we'll do, we will make a helper function. We'll make a helper function in which we will iterate through all the so we'll iterate through range 26. So 26 is nothing but the total alphabets which is present in the English. So then we have make a count. Count is nothing but an array of 26 elements which count the frequency of every character, right? So there are 26 characters, so that's why we choose 26. So then we will iterate through all the 26 characters, and we will check if the count of that character is greater than 0. That means the character is present in this count, right? Let's say B is present, so we have B 2 times, so we will choose B. Then what we'll do, so B alone is also a subsequence, so we will increase the total count. We will decrease the count of B, and then we will put this counts map in the new helper function, right? Or the other instance of the helper function, so which will count all the possible subsequences using the decreased B. Then we will again increase the count of B. Why will do that? Because we have to do this for C also, for A also, and for other characters also. So this is called backtracing, right? We will do some operations using one method, and we will backtrack that method, or we will go on another part, so removing the footprints of the previous methods, right? Previous paths. So that is called backtracing. So we have used backtracing here. So we have increased the count of B again, and then we will return the total number of counts. So what we will do, I want your attention again. We have counted all the frequencies of the characters. Now we will gonna count the number of subsequences which can be possibly made using these frequencies, right? So as you can see, positions are important, not the frequency. So we don't want the order, right? So order is not very important, so we don't want orders to be stored, so that's why we are just counting the frequency. Then we are making a function helper which help us to count the number of subsequences for a given frequencies of character, right? So how do we count that? So we will make a total counter. Total count is equals to 0 if we got any character which is greater than 1, right? So we will increase the count because that character also makes a subsequence. So A is also subsequence, B is also subsequence, A is also subsequence, B, all are these are different subsequences. So then we will decrease that count and we will count the subsequences of remaining counts, right? So that will be added in the total count. Then we will again increase the count of that character because we will gonna backtrace the process for other characters also. So what we will do for A, we will do it for B, and then we will do it for C. So that will make a tree like a structure, right? Let me explain to you. So for this given example, we have A 3 times, B 2 times, and C. So that will make three trees at the initial level. So we have first A, we have then B, and we have then C, right? For using this A, we can make we can make 3 different trees. So this has A, this has B, this has C, right? Then again using this A, we can make 3 trees. This has A, this has B, this has C. Now as you can see, all the frequency of A is gonna vanish there, because as you can see, we will continuously decrease the frequency of A in this path. Then we can make only 2 trees, right? One with B and one with C. Then at this B, so again we're gonna do the same thing here and here, right? And same with here and same here. So for going from A to now B, right? For this B, the total frequency of A should be 3, right? But we have decreased the frequency here of A. So what we'll do, we will increase the frequency again for so that we can use it in this tree, and again we will use those initial frequency in this C. So that's why we have increased the frequency, and that's called the backtracing, right? We have done all the operations in this tree. Now we will backtrace that process. We have just counted all the counts and then backtrace that process, and we will do for other processes. So that is called backtracing. So I hope you understand this approach well. So this is the code. We have counted. We have like counting the frequency. Then we are doing the helper function. We are counting the number of subsequences. So this is I've solved this problem. I will let me submit this. So yeah, this is getting passed. So I hope you understand something from this video. I hope you gain some valuable knowledge. Thank you for your time. That's all from my side. Again, I am reminding you to suggesting you to join the WhatsApp channel, WhatsApp group which I have created. The link is given in the description box. Also, please go through the playlist of LeetCode 75 and previous problem of the days, so that you will get a better grab on your DSA process, right? So thank you. Namaste.